Hello everyone, this is Jyoti. I am currently pursuing my BTech final year in CSE from Gokaraju Rangaraju Institute of Engineering and Technology. We are Team A7. Me and my teammates Rakshita, Venela, and Shreya have worked on the project titled Random Multimodal Deep Learning (RMDL) for sentiment classification using Coot political optimization. We are guided by Dr. Anuradha Ma'am, Professor, Department of CSE. I am here to present our project. Sentiment classification in reviews is vital because it helps the businesses understand customer satisfaction and guides consumers in making informed decisions. Our project aims to make it easier to understand whether reviews are helpful or not. We started by gathering a dataset which consisted of reviews from Amazon, giving us a lot of different opinions to work with. To handle all this information, we use something called as a map-reduce model, which splits the work into two main parts, sorting and analyzing. First, we use a tool called BERT to pick out the most important parts of each review. This helps us understand what people were trying to say and how they felt about it. Then we used a powerful tool called RMDL to figure out if a review was helpful or not. Then, to make sure it works really well, we used a novel method called Coot political algorithm that fine-tunes the tool's settings. Existing system. The current system uses technique called BERT, a powerful language model to analyze reviews without needing a manual effort. It examines review data from Yelp to understand sentiment. BERT outperformed traditional methods like KNN, naive Bayes, and SVM in accuracy in predicting helpful reviews. This highlights the importance of fine-tuning models for optimal effectiveness. Proposed system, our improved approach. We propose a more efficient system for sentiment analysis built on the MapReduce framework. It uses a powerful deep learning model called RMDL combined with transfer learning. It works in two phases. First, the mapper phase. Here, the reviews are broken down into smaller units called tokens using BERT, and the key aspects are identified. The second phase is the reducer phase. Here, the RMDL takes over, analyzing sentiment using pre-trained models and unique optimization method called CPA or Coot political algorithm for better performance. There are three key advantages. First, it leverages the power of MapReduce for large datasets. Second, RMDL and transfer learning improve sentiment classification. Third, Coot political algorithm optimizes the model for better results. Implementation, bringing the system to life. To build our system, we'll follow these key steps. First, data acquisition. We'll gather real world review data, which is the lifeblood of any analysis. Second, data cleaning. We'll ensure that the data is clean and prepared for analysis, removing any irregularities. Third, distributed processing, which is MapReduce. We'll leverage the power of MapReduce to handle large datasets efficiently. Fourth, review breakdown. BERT will be use it to break down the reviews into smaller units for easier analysis. Fifth, sentiment analysis. RMDL with transfer learning will then analyze the sentiments within these units. Sixth, optimization boost. A unique optimization method, CPA, will be implemented to further improve the model's accuracy. Last, testing and evaluation. Once the model is built, we'll thoroughly test the system with real data and compare its performance to existing methods using precision recall and other metrics. Class diagram. This diagram shows the key players working together in our system. First are the reviews, the individual documents we analyze, like athletes with their review content. Second, the preprocessor, the data cleaner preparing the reviews for analysis using BERT. And third is the RMDL model, which is the star player analyzing the sentiment with transfer learning. Next comes the activity diagram. It showcases the key activities which are performed in the system. First is start. The system begins by triggering the data collection process. Next is data acquisition, where reviews are gathered from various sources. Third is data preprocessing. The acquired data undergoes cleaning and preparation using the preprocessor class. This might involve tokenization with BERT, removing irrelevant information, and formatting the data for analysis. Map phase. Individual reviews enter the MapReduce framework. Each review is processed by a map task which performs processing and generates key value pairs based on aspects or sentiment categories. Next is reduce phase. The reduced task takes over, grouping reviews based on keys and utilizing the RMDL model for sentiment classification. The Coot political algorithm might be integrated here for model optimization. Output: the final sentiment analysis results are generated and stored for further use. End: the system reaches its conclusion. Project architecture. The project's complete architecture for sentiment analysis using hybrid deep learning model within the MapReduce framework and its key components are shown below. The first is data collection. This block, this block represents the process of gathering reviews from web sources like Amazon product reviews. Next is the pre-processing layer. In this, we have two parts. First is the mapper phase, and the second is the reducer phase. In the mapper phase, we have BERT tokenization. This stage uses a pre-trained model BERT to break down reviews into smaller units or tokens for easier analysis by the model. Second is aspect term extraction. Here, important aspects of the topics mentioned in the reviews are identified and separated from the rest of the text. In the reducer phase, we have two parts: RMDL model and CPA optimization. In RMDL model, this is the core sentiment analysis engine of the system. It leverages transfer learning where a pre-trained model is adapted to the specific task of sentiment classification in this case. Then CPA optimization. This is an innovate element which is used for unique optimization method and to fine-tune RMDL models. Potentially, it enhances the accuracy of the sentiment classification. Next is the output layer. Here, the data is stored in a designated format, potentially a database for future use. Next is testing and output generation. This block refers to the evaluation process where the model's performance is measured using metrics like precision, recall, and etc. Now, let us look at the data collected. The data collected contains about 5,68,454 reviews. Therefore, for the purpose of simplicity and to reduce the amount of time it takes to run the model, I have copy pasted first 50 reviews into another Excel sheet and titled it as sample reviews. And the code we will be seeing will run on the same sample reviews file. So let us check out the code. First, the necessary libraries are imported, including pandas for data handling, torch for PyTorch, and transformers for BERT related functionalities. Next, the dataset is loaded from CSV file containing reviews. The CSV file is termed as sample reviews.csv. Then the data is pre-processed, selecting only the text and score columns and maps the scores to binary helpfulness categories. Next, the data set is split into training and testing sets. Then the text data is tokenized using BERT tokenizer. Next, the labels are converted into numeric values and data is sent into PyTorch tensors. Next, the pre-trained BERT model is loaded for sentiment classification. Then the batch processing is set up using PyTorch data loader. Then the optimizer and the loss functions are defined for training. Next, the model is trained over specified number of epochs, computing average loss per epoch. Then the trained model is evaluated on the testing set, calculating the accuracy. Then the predictions are made on the testing set. Next, the predicted labels are mapped back to the original helpfulness category. Finally, the predicted labels for each review are printed out in the testing set. This is the output of the code. Here it shows the average loss for the three epochs which we have run, and the accuracy of the model is 80%. Then the review summary of each review is presented, and helpful reviews are given the predicted label as helpful. This was how the task of sentiment classification was accomplished using BERT and RMDL on the data set of Amazon product reviews. Thank you.